Aim of this section or this video actually is to understand or to answer why must fractions have the same denominator to be added or subtracted. And the second question we are trying to answer is why does the denominator remain the same after the process of addition and subtraction. Now, before I go to the reasoning, I have a small question for you guys. Look at this and give me the fractional equivalence of this. What fraction is this equal to? This is 1 and this is 20. So basically what I'm trying to tell is there are 20 parts over here. This is 19, 18 and 17. So what fraction are we looking at? Correct, 17 by 20. Now, let's look at an example, 3 by 5 and 1 by 4. So 3 by 5 and 1 by 4. Let's look at it, how it looks actually. So we have 3 by 5, so I need 5 over here. And 1, 2, 3 over here. And then we have 4 over here, 1. So this is our 3 by 5 and 1 by 4. Let's copy this. So for me to add, we need to, okay, let me do this. We need to do this. We need to stack the numbers. So let me do this. I copy this and I do this, and let me copy the other part as well and paste it over here. Now, till now we have seen a lot of fractions and everything. Does this particular situation represent any fraction? Does it represent any fraction? Answer is no. It does not represent any fraction. But why? Actually, I should be asking why not. Reason being, what is the reason? Yes, because fraction is always what? Fraction deals with equal parts. So here the parts are clearly not equal, and so we cannot count this. So we cannot. The question is, can we count? Can we count the parts? So this was the question. Answer is no. It does not represent any fraction, or we cannot count. We cannot count a fraction or parts. We cannot count the parts, the division basically. And we understood the reason as also. Reason because fraction, remember, deals with equal parts, right? That's one of the things that we stated very clearly. So reason being this. This was the question. Now let's actually do the step. So we have 3 by 5 and being added to 4 by 5. So before adding, we have to figure out the LCM of 5 and 4. In this case, it's 20, and then convert 3 by 5 to have a denominator or get an equivalent fraction wherein we have 20 in the denominator. How do we go on doing that? So I'll write 3 by 5. I'll have to multiply 5 with something so that I end up with 20 over there. So it has to be correct 4. As per the procedure, this we need to multiply the numerator also with 4. And so we have 12 over here. Next is 1 by 4. Again, remember, I need a 20 in the denominator. So 1 by 4. So what should I multiply so that I get 20 over there? 5. This is 5 by 20. Right? Now, I'm telling that we can add 12 by 20 and 5 by 20. How so? Let's have a look. So this is 20 parts, 20 parts. The first one is 12. And the other one is 5. Now, if I happen to take a screenshot and do this, okay, and do a bit of manipulation. Let me actually do this again. So the result is combination of this, and see, I'm doing this in front of you guys. So there's no, I'm not tricking you guys. Okay, I'm copying this, I'm pasting it over here. Okay, forget about the colors being different, but do we have the same parts and are they overlapping, and can we count this? How much is this? So we have, remember, this is 20 parts. So 20, 19, 18, and this is, yes, this, what we're looking at over here is 17 out of 20 parts. Do you guys agree? Right? So this answer has to be 17 by 20. Now, we have one more question. Why is that we're not adding the denominator? So what is this fraction again? Guys, what is this fraction? 17 by 20. Did the number of division change? No. To answer the point B, since the number of division does not change over here, after adding, I did this addition, right? I added this too, and I got this. So post addition, the number of division, post adding, the number of divisions is not changing. And so remember, denominator counts the number of division, and so denominator remains same. Okay, did we answer both the question? Why must fraction have the same denominator to be added or subtracted? Yes, we answered this. Why does the denominator remain the same after adding or subtracting the numerator? So it goes back to this particular point you guys made at the start. This fraction represents 17 by 20. It doesn't matter how many things are selecting, the number of division is not changing over here, right? So here it was 12 parts, here it was 5 parts. Combined, there are 17 parts that we are selecting. But the number of division in this two, right, in this two, they're not changing. And so we have selected 17 parts out of 20. And so this represents 17 by 20. Okay. So yeah, please copy all of this. Very important. Try to put it in your own words. Try to draw. I know this is a bit tedious, but yeah, please try doing it.